Kia ora, hello, namaste, ni hao. This is Prashant again, and we shall be continuing with our Fortinet series of labs and discussions. This video has been created for you to understand the theory of how to implement SSL VPNs for your organizations using Fortinet devices. This is lab 12 in the Fortinet Security Guide Operating System 6.2 series, and the details of this lab are mentioned on page 195 till 211 on the guide. This video will cover the SSL VPN basics and in specific the bullets mentioned on the slide. We shall describe what an SSL VPN is, we'll see what the deployment modes are, and then also have a quick look at how to configure the SSL VPN and what's required for that. This video would assist you in better understanding the concept of what a SSL VPN is and the other variants of VPNs, and in you to complete the lab quickly. The virtual machines you need to use for this lab are Linux, FortiManager, local FortiGate, local window, and remote windows. In this lab, you will configure the SSL VPNs, which are an easy way for giving people remote access to your private network. If you watch this video and read through the guide, it should take you approximately 25 minutes to complete the lab on your machine. For those of you who are using either the virtual instance of it, the RDP version, or you're using your instant machine, it is essential that prior to starting this lab, that you should restore the original file to the local FortiGate firewall from the folder on the local virtual machine VM desktop. It's located in the folder resources, initial lab environment config, and upload the file local-initial.config to the local FortiGate. Now the file will reset all firewall conditions and you will not have a problem in the network if you configure the details as per instructions. Now while doing the lab, the local FortiGate config files are located in the resources, security, SSL-VPN folder, and it's mentioned in the lab guide. Please adhere to that. In addition, for this specific lab, you need to clear the browser history of the browser, that's Firefox, prior to the start of the lab. Also remember, you need to use the remote windows to switch this VM. So switch on this VM after the local windows has been switched on. So from within the local windows, you will open a Firefox and connect to the remote windows as well. So be careful on that count. Now, before we start the lab as such, we need to understand what are VPNs. A VPN simply extends a private network across a public network. It creates a tunnel that gives users or even remote LANs secure access to your private network as if they were connected to your LAN. A VPN is often used when LANs are separated by untrusted public networks, such as maybe the internet, as well as providing users with secure access to private networks while they are traveling. Now, a VPN can also interconnect branch office networks located across the internet and even to the other side of the world. I do realize that some of you use VPN for gaining access to certain websites or certain gaming things which are geo-enabled. That's another not authorized method of using a VPN. Now, user data inside a VPN is encrypted for privacy. It cannot be read even if it is intercepted by unauthorized users. So a man-in-the-middle attack would normally not function when you have a VPN in place. VPN also uses security methods to ensure that only authorized users can establish a VPN and access the private network resources. They typically also provide tamper proofing. It is normally encrypted so that the unauthorized users can't eavesdrop. And most VPNs are SSL or IPsec VPNs. Now FortiOS as an operating system supports both, as well as the common weaker VPNs such as the point-to-point tunneling protocol or PPTP. In this particular lab, we are going to focus more on the SSL VPNs. Now a quick look at identifying the differences between the two VPNs that are commonly supported in the industry. Now, first and foremost, the protocols itself are different, right? So if you try and differentiate SSL VPN to IPsec VPN, as the table says here, uh, the protocols are different. Now, SSL and TLS are commonly used to encapsulate and secure e-commerce and online banking on the internet, basically HTTP. Now, SSL VPNs use a similar technique, but often with non-HTTP protocols encapsulated. SSL resides higher up on the network stack than IP. Therefore, it usually requires more bit, which translates into more bandwidth. So for SSL VPN headers, it will definitely need more bandwidth. In comparison, IPsec uses some special protocols. The primary protocol is ESP, which encapsulate and encrypts UDP, RDP, HTTPS, or other protocols that are inside in the IPsec tunnel. I'm sure that most of you know of these protocols or have read them in the past. If not, please do some study and read about these protocols. It will definitely help you in future. Also, IPsec VPN is a standard. It can interoperate with multiple vendors and support peers there that are devices and gateways, not just using client with FortiGate only, like SSL VPN does. The client software is also different. In SSL VPN, your web browser might be the only client software you need, like in this case. You can go to FortiGate's SSL VPN portal, which is the HTTP page, and then log in. Alternatively, you can install a plugin or a Forti client. Now, this increases the number of protocols that can be sent through the VPN tunnel. In comparison, to use a IPsec VPN, you usually require to install special client software or have a local gateway, such as a desktop model, etc. You might also need to configure firewalls between VPN pairs to allow the IPsec protocol. However, IPsec is a standard protocol that is supported by most vendors. So a VPN session can be established not only between two FortiGate devices, but also between different vendor devices and between a gateway and the clients. It's highly extensible and configurable. By comparison, a SSL VPN can only be established between a computer and a vendor specific gateway such as a FortiGate. So if you're using a FortiGate alone, then perhaps you may end up just using the SSL VPN version of the VPN, right? So just getting on to a couple of other things in the, like, if you logged in, the SSL VPN connects to your computer. You connect your computer to the private network. You don't really require too many user settings for a SSL VPN, and the firewall are typically configured to allow all kind of HTTP traffic to go out. So technical support calls are less likely. Simplicity to make a SSL VPN is ideal for non-technical users or users who connect from public computers, right? So it's a preferred form of connectivity. Point to point, or one person connecting to a headquarters, SSL VPN, multiple different base offices if they need to connect across office to office traffic, data centers, maybe you will be using a IPsec VPN. Now, let's do a quick knowledge check. The first question is, what does a VPN do? So I'll stop here and you guys can start the answer. And the second question is, which statement about IPsec and SSL VPN is true? So you have the two options there. The thing is there. You can write one and the answer, whichever you think is correct. And you could either write two and the answer, and we'll see what goes there. All right. Let's now look at how SSL VPNs are deployed and what are the modes in which it can be deployed for Fortinet devices. Now, there are primarily two modes you can use to access an SSL VPN. Both can build an SSL VPN connection, but they don't support the same features. Now, which should you choose? It depends on which application you need to send through the VPN, the technical knowledge of the user, and whether or not you will have administrative permissions on your computer. Now, the first mode is a tunnel mode. It supports most protocols, but requires the installation of a VPN client, or more specifically, a virtual network adapter. Now to tunnel traffic using the virtual adapter, you must use the Forti client or its standalone Forti SSL VPN client component. So that's the requirement of the tunnel mode. And then you got a web mode. The web mode requires only a web browser, but because it only requires a web browser, it supports only certain limited number of protocols. Now those protocols are Citrix, file transfer protocol, hypertext transfer protocol, HTTPS as well, port forwarding, RDP, SMB or CIFS, SSH, Telnet, VNC, and ping. So these are the only protocols that a web mode actually supports. So let's look at what the web mode actually provides us. Now, web access is the simplest SSL VPN mode. Like you would with any other HTTP website, you simply log on to the SSL VPN portal web page on FortiGate. It acts like a server-side reverse proxy or a simple, secure HTTP/HTTPS gateway that connects you with the application on the private network. Now the bookmark section, which is mentioned here on the SSL VPN portal page, contains links to all or some of the resources available for the user to access. Now the quick connection widget allows users to type the URL or IP address of the server they want to reach. A web SSL VPN user makes use of these two widgets to access the internal network. Now the main advantage of web mode is that it does not require you to install any extra software. That's the biggest advantage you have. However, web mode has two major disadvantages as well. Now, the first one is that all interaction with the internal network must be done using the browser exclusively. Now, it could be through the SSL VPN portal or external network application running on the user's PC. They really cannot send data across the VPN. And the second major issue is that it supports only limited number of protocols. So let's understand quickly how the web mode works. So the remote user connects to the SSL VPN portal, that is HTTP web page on the FortiGate. The user authenticates. Then the user access resources through the quick connection launches or the browser. Now, different users can have different portals with different resources and access permissions. Please notice that the source IP seen by the remote resource is FortiGate internal IP address and not the user's IP address. So there you have to be careful as to if you're doing a reverse proxy on that, you will very quickly appreciate that the IP address seen by this device is not of the user, but it is of the source IP. It is replaced by the FortiGate's internal IP address. Now, tunnel mode is the second option FortiGate provides to access resources within an SSL VPN. Now, tunnel mode requires Fortinet's standalone SSL VPN client, FortiClient it's called, to connect to FortiGate. Now FortiGate adds a virtual network adapter identified as a Forti SSL to the user PC. You will be utilizing that in your lab. The virtual adapter dynamically receives an IP address from FortiGate each time FortiGate establishes a new VPN connection. Now inside the tunnel, all traffic is SSL/TLS encapsulated. The main advantage of tunnel mode over web mode is that the VPN is established. Any IP network application running on the client can send traffic through the tunnel. So even if you have a local machine or a streaming machine working on your network, you can actually start to stream it there. That's why it has its advantages. It supports multiple different applications there. However, the main disadvantage is that tunnel mode requires the installation of a VPN software client, which requires administrative privileges. So it cannot just be installed if you so desire it. Now a quick look at how the tunnel mode actually works. User connects to FortiGate through the Forti client. The user provides credentials to successfully authenticate. FortiGate establishes the tunnel and assigns an IP address to the client virtual network adapter or the Forti SSL. This is the client source IP address for the duration of the connection. Then user can access services and network resources through the encrypted tunnel. Now FortiClient encrypts all traffic from the remote computer and sends it over the SSL VPN tunnel. Now FortiGate receives the encrypted traffic. de-encapsulates the IP packet and forwards them to the private network as if the traffic originated from inside the network. So it's slightly different from the way it works with the web mode, but it's a more comprehensive and a better way of working, in my opinion. Now, the tunnel mode also supports split tunneling. Now, when split tunneling is disabled, all IP traffic generated by the client computer, including any internet or regular internet traffic, is routed through the SSL VPN tunnel to the FortiGate. Now, this sets up a FortiGate as a default gateway for the host. You can use this method in order to apply security features to the traffic emanating out of any remote client, or to monitor perhaps or restrict the bandwidth usage of a particular PC. However, it does add latency and increases the bandwidth usage. Now, when split tunneling is enabled, only traffic that is destined for the private network behind the remote FortiGate is routed through this tunnel. All other traffic that is set through the usual unencrypted route will be going normally as it would otherwise. Now, split tunneling helps to conserve bandwidth and it alleviates certain bottlenecks. Right. So this gets us to the end of the presentation and a quick knowledge check. The first question is, a web mode SSL VPN user connects to a remote web server. Uh, what's the source of the IP address of the HTTP request the web server receives? So this is the first one. Question number two, which statement about tunnel mode SSL VPN is correct? It supports split tunneling or it requires a bookmark. Question number three, a web mode SSL VPN user uses dash to access internal network resources. Now I've just covered that in the previous few slides. Please give it a thought and then we can have a quick discussion about what the correct answers are. Thank you. This kind of completes the video for SSL VPN. You can now ready to do the lab. So let's get cracking on that.